Okay, this is question 10.4, and we're going to 10.4, not 10.5. 10.4. Let's just try it. They give us that CF is 6 and that AB from A to B is 24. So I've written in 6 and 24. And they ask us to calculate what AE is all the way across. Well, often when you're working with circles and you've got a center, one of the things that makes things a little bit easier is to work with all the radii. Now you know that AF and FE equal each other, and you know that BM and ME equal each other because they're radii. We know they're equal to each other because we proved it before. We knew that, well, because of a perpendicular line from the center. And so if that's true, then FM has to equal 1/2 AB. And why is that? Well, look. Because we've just joined the midpoints. It's the midpoint theorem. You've got a triangle in here, AEB. You've joined the midpoints of the triangle. So that means that FM is going to be half of what AB is. That's what the midpoint theorem. It says they're parallel and that FM is 1/2. So now we've got FM is 12. Well, that's kind of nice because that gives us CM, which is a radius. So EM and MB and CM, all of them, the radii, all of these radiuses, if we went from M to B, from E to M, and from C to M, it's all 18 units because they're radiuses. Therefore, EB, that distance from E to B all the way across, if it's 18 and 18, it must be 36 units. Well, we've got a right angle triangle here. We've got one side is equal to 36 units. We've got the other side's 24 units. We can use Pythagoras. The hypotenuse squared minus the short side squared there. Square them, subtract them, take the square root, and we've got AE, what we're trying to figure out, which is 12 root 5. And that's it. So we got to use that idea because we know that angle A is 90 degrees. That's why we can use Pythagoras. And there we go. We had to use the midpoint theorem to be able to get at that. I think I did it in a different way. Let's see. Did I do it in a different way? There is a different way to do it. You can work with the radiuses being equal and these sides. You can work with these other two sides, but essentially do something very close to the same story. You can take a look when you look at the look at it closely. I guess I could go through the whole thing kind of closely. But this time, FM is 12 units, but we work with different radii here. And FE squared equals 18 squared. 18 squared minus 12 squared. Looking at a different, I think, right angle triangle here. Let's see. FE squared equals 18 squared. Oh, looking right here, they're using just this part here, 12 and the 18, you see. 18 squared minus 12 squared, they get it FE, and then they double it. And I think I did it in a scary way. I won't even go through it all. When I did it, I don't know, I was thinking algebra, and I thought of these two B's together. I called them B. I looked at the radius. I saw that all the way across is two radiuses. I used Pythagoras and created a formula, and then I did another one for, I knew that this was the radius minus 6 would be this area. I created two formulas, and I did substitution, and I got to the same answer. Ooh, that's too many. That's a little bit complex. You could stop the video and take a look at all the algebra I did, but I don't recommend it. Well, actually, you could. Maybe you'd like to do it. That'd be all right.